So, good evening to you all. So, good evening and welcome to this today's sessions of the lecture series by the Ladakh Science Foundation under the emerging technologies. Emerging technologies, and today's speaker is Dr. Yogesh Parte. So, he'll be speaking on the data science topic today. So Dr. Yogesh Parte, he is from Mumbai, and he is earlier he was in ISRO. We joined together in ISRO, like we were the batchmate, and he was a scientist in ISRO. He worked for 3 years, then he made a life in a different field. Now he is a data scientist. Dr. Yogesh, he did his B mechanical engineering from Pune University, then MS in aerospace from Indian Institute of Science in Bangalore. Then later on, he did Ph.D. in applied mathematics from Toulouse in France. Till now he has around some 17-18 years of experience in the various fields, various fields, primarily in the algorithm development, concept of proof of concept demonstrations, and in the first field of artificial intelligence, machine learning, and so many areas. He has worked. Presently, he is a data scientist listed in CitusTech Mumbai. And earlier he was the co-founder of the global InnoLab solution Mumbai in 2017. Then before that, he was for a short while he was a joint faculty in SP Jain School of Management Mumbai. Then he has also founded one YP Consulting Services. Here he has made this as a very successful one from 2012 to 13. And then for a short time he was also a faculty in learning Mumbai. Then after during his research time in France, he was working as a research and development engineer in France. Then a lot of things, like the list goes on. Then 2003 to 5, he worked as a scientist in ISRO. During that time, I had an opportunity to, interact with him. He is a very good friend of mine, and we did our ISRO training together. We know him very well, and he's not only in the technical field, he is very good in socializing, good tracking, music, and Skywatch. But he's a multifaceted personality. I welcome Dr. Yogesh, all the participants, students, and many of my friends who have also joined here. So thank you all for coming to these sessions. Now I request Dr. Patre to start the session.
Hello everyone, this is Yogesh here. I hope you can all hear me clearly, right?
Yeah.
Fine, good. Fine. That's good, right? So thank you for the introduction, Tashi, right? Okay. After hearing all that, you may be thinking, what is this person, right? He's not in just one field. He might be just, moving from one field to another. What is that he's doing for last 17 plus years, right? Sometime I hear he is doing aerospace. Sometime I hear he is doing Nutri-analytics. Sometime now you're telling me he is a data scientist. So what is this all about, right? So if you really look at, apparently it may feel that there are altogether different fields, right? But if you really look closer and see what is the main thing that binds all these fields is nothing but data, right? When we have a data, how do we interpret them? How do we use them for maybe design, for application, and multiple kind of things? So for last 17 plus years, right, what has been a common thread across all this discipline is the data and related science. And that's the reason today we are going to hear something about data science. Now, all of you must be hearing, right? Machine learning, AI, right? Every day there is, if you open the news portal, you will see something or other going on. Now, the talk today, right? I mean, this is, what I want to give you is a fair bit of idea of what data science is all about, right? The way you hear it feels it's something out of the world, something which is only for elite people, right? Possibly know a lot of things about mathematics, algorithm, only those people can do it, right? I'm a biologist, maybe I may not be able to do it. No, it's not the case, right? I mean, my primary, right, discussion of today will be close, right, mostly focus on that aspect, right, that anybody can do data science. How many of you seen movie Ratatouille? Have you seen that animation movie Ratatouille, where there is a mouse, right, a rat, right, who wants to learn, become a chef in the world, top chef in the world? Have you seen that movie? Anybody, right? Maybe you can just raise the hand in your digitally, right? Anybody has seen movie Ratatouille? A rat who wants to become a chef? No, nobody? Okay, if not, just see that. Okay, yeah, somebody, right? Shabir has seen it, right? Shabir, do you know the famous dialogue from that movie? The famous dialogue of Gustav, the chef, right?
I don't remember the dialogue, but I have seen the movie.
Okay,
My daughter used to see a lot that movie.
that's right. That's one of my favorite movie, and one of the dialogue there is that anybody can cook. Okay, right?
Yeah,
And right, so Gustav, the chef, right, tells them, and that rat gets motivated from it, right? And then he wants to become a chef. So today's talk, right, is more about similar thing. What I want to tell you, anybody can do data science, okay? But like to become a good chef, we have to, right, try our best, have that grit, right? It's similar thing. If you want to become a data scientist and contribute to data science, it's possible, irrespective of your background, okay? What is more important is your enthusiasm. What is more important is understand what is needed, right, to do it. So this is where I have just structured some of my thoughts, right? I'll be driving my thoughts to a small PowerPoint presentation, and I promise it will be more or less interactive session, right? Because you should not feel bored after 5-10 minutes. So I may be posing some questions to you. If possible, try to answer them. I know being a distant one, it is difficult, but we can follow small protocol. If you're all aware, right, in your Zoom, right, you can say you have an option to raise the hand, right? So I would request Tashi to be the moderator when I put a question, right? You raise the hand, and maybe Tashi has a privilege to, say who goes and, right, answer the question. Is that okay with all of you?
Yeah.
Right, good, right. So yeah, that's right. Another way, right, we will use little bit of sign language, because if we all go on mute, it can become a chaos, right? So when you are in for what else, or when you want to say yes, just raise your hand and put thumbs up, okay? And if you want to say no, right, then put it down, okay? Is this protocol okay with all of you? Okay. Good, very good. Okay, that's great. Right, so let's get started, right? I will share my screen, and first 5 minutes, right, let's be very attentive and see what you want to see and what you're going to see, okay? Right, give me a minute, right? I'll just go to my presentation, start sharing a screen. And remember, right, when you are with me, I will make you think, okay? Right, so give a thought, right? What is it all about? And think about it, okay? Fine, give me a minute. I'm just adjusting the screens of my. It's a small check, right? If what is that you're able to see or not. Okay, I started the screen, it's buffering at the moment. Some of the things. Okay, here we go. What is that you're able to see it now on the screen? Do you see something named data science on a screen?
Yes,
Yes, right. So that's where we start. Okay, fine. So all about data science. What is it all about, and how can you contribute to this field? So here comes the very first thing. I hope you are all able to see it. Do you remember something of similar sort you solve sometime. If I give you certain patterns, let's see. Let's see the first row. There are 2 squares, right, in blue color, 2 circles in blue color, or ovals in blue color, and then again there is 1 square. And I'm asking you, what could be the next image, right, in that row?
Squares, sir.
Square?
Yes.
Okay. Everybody? Sure?
Yes, sir. Sure.
Yes,
Okay,
sir.
great, great.
Sure.
Now let's go to next line, right? And look at that line. And if I ask you, what could be the next in pattern? Can you help
A
me?
square in a red color.
Orange square, sir.
Red,
Okay.
red color square.
Red color square, great. Okay, right? Just whatever you are uttering, right? Just note it down, because we will come back to this later. Now, the last line. What could be the pattern or the next image there?
Red color square with the F.
Red color square with F. Anybody wants to differ from it?
Yeah.
Anybody? Or everybody says red color square with F?
Yes, sir.
Everybody agrees, great, right? If you can solve this,
Yes, sir.
welcome, you know data science. Okay, right? Just take a screenshot of this, keep it in your background. We will move to next slide, okay? What is this?
Mahatma Gandhi.
Mahatma Gandhi.
Everybody? Mohandas Gandhi. Everybody says the same thing? Anybody
Yes,
wants
sir.
to differ?
Sketch of
Actually, it seems to Mahatma Gandhi, sir. So maybe it is Mahatma Gandhi.
Mohandas
Okay.
Gandhi.
Okay, great, right? Just good, very good, right? Remember, see, this is what you know, data science, right? There is nothing different. Now, if somebody says this is Mahatma Gandhi, right? How can you make out? I see the image which I know of Mahatma Gandhi. He has spectacles, right? He has a big nose, maybe smiling, the way you see it on 500 rupees note. But all those things are not there. Still, you are able to make out. How can you make out this? How did you make out this?
Because we have seen this image many times before.
Okay, right, good. And how much time it took you to take this decision to say this is Mahatma Gandhi?
Few seconds.
Few seconds, right? Maybe a microsecond, right? Just keep that, right? The process by which you actually saw the image and then you applied a label to it saying Mahatma Gandhi. Just go back in your mind and see what all happened when I posed that question to you. Okay? Try to just register the process which allowed you to do this. And keep that in your mind. Keep that in your mind. Okay? Now, with this too, we will go to next one. Okay? I hope you're enjoying it, right?
Yes, sir.
Well, do you know them?
Yes.
Now,
Barack Obama.
who is a real picture, say Barack Obama, and which is possibly not real?
Actually, as far as I guess, it is virtual versus real, sir.
Okay. But if I ask you,
both
tell
at
me
the
which is
left and right corner are real.
Okay, very good. Okay, just keep that in mind. Now, anybody wants to differ?
Was the
Anybody
last
know?
one? They have their different passions. You can see.
Okay, right. But then I'm a little surprised, each one of you, right, saying the first image is of real Barack Obama, last image is of real Mr. Shah Rukh Khan. But then what made you to differentiate between the real Barack Obama and do you know who is in the second image of Barack Obama
Shah Rukh
look
Khan.
like? No, no, Barack Obama's look like. Do you know that personality?
No.
Okay. Yes,
Name.
exactly.
Actually,
That's right. Indonesian PM, right? So, but then, right, do you see? But then what made you think that he is not Barack Obama? Whatever
Because
goes in your
actually we have
mind.
seen.
No, don't disclose. Don't disclose. Keep that in your mind, okay? Keep that in your mind. Go back, right? And think about the process which allowed you, right, to differentiate real Barack Obama from an Indonesian national person who looks like Barack Obama. How did you know that which is real, which is not? That process, right? If you understand what we do in machine learning, what we do in artificial intelligence, what we do in data science. Okay? And I'm so happy to see all of you, right from that first slide till now, you could actually decipher those mechanisms. Data science is not something outside, it's within inside us. It's day and night, right? Yeah. May I request all of you to go on a mute, please? Okay, fine. So let's just be on a mute. That will help us. I understand there could be certain challenges, but if you're on a mute, then it will be better. Fine. So this process, right? If you know, then we are very good. We can do data science, right? And it is not something outside. It's all around us. Okay. Let's see something more in detail. Right? This is a research which was carried out in UK where people looked at the thermogram, how the temperature distribution over human body, right, is when people are in different emotion. When they are angry, how is the temperature distribution? When they are surprised, what is the temperature distribution? And what they found, there is a definite pattern, right, of how our body temperature distribution changes based on our emotion. It's a well-proven research. I have given you the link as well. If you're in, I will be sharing this with all of you. Just go and see what beautiful studies there. So you can actually, put a infrared detector, see body temperature, and can tell in what emotional state people are, right? Now, whatever you see on a screen, just take a screen grab, keep it at the background of your mind, and then we move to the next slide. This is another parallel research, which also looked at how do people movement, body movement, can they indicate their mental state? Can they indicate their emotions, right? Again, this is a well-researched published study way back in 2008. And it proved that the way our gestures are, even now, when I'm talking to you, right? If we record and use certain pattern recognition technique, then we can tell in what emotional state people are. Okay, take a screen grab of this, right? So you have two images, one of the thermogram, second is of people motion when in different emotional state. And now, right, I will tell you what is that people like us do. Given these two set of information, can I develop certain kind of application which will help mankind, which will help people, which will help society? I will just take a pause and ask you, looking at these two set of information. One, we say from thermogram, we can tell emotional state. Second, by body gestures or movement, right? We can tell you the emotional state. And I am asking you a question, can this be utilized in some way? But again, I will give you one more hint. This is what we call biomotion analysis, right? The study which studies human motion, human animals motion, and try to decipher what are the parameters, what are the influencing factors which decide this body motion. Okay, I will show you a live demo of it, and then you will try, maybe just to enjoy, right, how it is. So let me just minimize the screen. Okay, and I hope you're able to see the screen. Do you see a man, somebody walking?
Yes,
on a
sir.
screen? So this is a real model which we develop out of, observing different people. Now, suppose if it's a more feminine nature person, right? I'm just moving the slider. Do you see that here?
Yes, sir.
Do you agree? If there's a more feminine nature, the walking style is like this?
Yes, sir.
Okay, this is, we are looking from front, okay? If you look from sidewise, right? Now I will make them very heavy. Okay. Right. Do you see a pattern? Do you feel this is what you typically see, a pattern? And then I will try to change their emotional state. I will make them very sad. Have you observed people walking like that if they are heavy, little nervous,
Mm.
and right? Let's see how a man, if he is in nervous state, how he will walk. Now, this is a real data. This is a real model that we have. Now,
Yes,
you have
sir.
seen this, right? So there are different factors like gender, weight, nervousness, emotional state of
Happiness.
happiness can decide, right? Actually, how we walk, how we have our postures. Okay. So you have now three set of information: thermogram, body postures, and this biomotion analysis. And I am asking you a question. Can you use all this information and do something which is meaningful for society, meaningful for mankind? Okay. So I will take a pause of say 30 seconds. Okay. And that's a question to you. And I would ask my friend Dashi to, moderate and see, right, who has an answer for it. And by that time, I would keep my presentation ready again. I think Shabir wants to say something, Dashi.
Yeah, this mechanism or this mathematical model tools we can use at various airports and security regions to see the, physical appearance of the persons or a terrorist. Definitely, the appearance or the walk and everything will be different for a normal guy than a person coming with a bomb or something like that. There we can use this sort of algorithms to see or check. I feel like that.
Very good, right? Now, again, right, may I know, Shabir, what you do?
I belong to Leh and I'm a scientist in DRDO.
Okay, great, right? So maybe, right, you have a little more weightage, but then what you answer is exactly we produced in 2009. Okay, that is what we are going to see it now. Okay, but it's not as simple as it sounds. But what Mr. Shabir said is exactly right, something what we did way back 10 years ago. And I will quickly show you, right, how this disparate source of information can be utilized to create something which is meaningful, right? So this is the question that I'm posing, right, to ourselves. Can we recognize emotion from body postures and thermogram? One of the challenge that we may have, if it's an individual, it's easy, but suppose people are in group, can I still be able to identify individual person's emotions from these thermograms? Can I link these emotions, right, to biomotion analysis and use that for threat perception? Just looking at how people are walking, how people are behaving for a few minutes, can I tell, is there a threat from this set of people? If I use this kind of biomotion analysis, can I predict possibly that person is going to fall down? Just to tell you, I work in a healthcare field now where people above age 60, right? They have 15% chance of having injury due to fall. When they become 70 years and more, the injuries due to falling down, right? That risk increases to 60%. And if they are 75 and above, then the risk of falling down, right, because of not able to maintain balance is almost 90%. Now, how this information is useful? This information is useful for hospitals as well as for insurance companies, because if they fall down, insurance company will have to pay for their bill, right? If they fall down, then hospitals will have to have some kind of mechanism to take care of them. But using this kind of analysis, what if we can avoid those falls, right? That is something we tried and demonstrated way back in 2018 as well, right? And something which I'm working for last 3 years is in epilepsy field. Using this biomotion analysis, can we predict maybe in Hindi? In fact, by this kind of motion analysis, we are able to if person is going to 30 minutes or so, right? And we are still doing many things in that field. But just to tell you, right, there are multiple applications that we can build. But now, how could you do that? Because what you had is a data. You knew there are certain patterns and there are certain factors which influence those factors. If you take care of all of this and use this, you are doing data science. Okay. So do you agree, right? Anybody can do data science? Yes or no?
Yes, absolutely, Yogesh. We already started feeling many data scientists.
I will be more than happy, right? One of my theme is called democratizing data science. Okay. Data science is nothing something for very privileged people. It's for all of us, right? So let's see, let's move ahead and quickly see what we did way back in 2009. Okay. This system, which I'm going to describe, is actually operational on the streets of Europe. Okay. Fine. So this is what we are asking us, right? Can I identify motions and create, right? Classify images and temperature distribution and use that to predict for threat perception. So automatically, right, when we come to this, what we need to know, right, is what's the algorithm that I will use, right? What is that? How can I know it? But it's not the only case. When I create this algorithm and actually use an application, it has to have a good accuracy, less uncertainty. It should work not only for individual, but also for people in group, right? It should be programmable so that anybody can take this, create a software, right? And mass produce and put it across different places. Execution time, right, for this should be as small as possible, within a few seconds. If your algorithm or your software is taking half an hour to recognize whether the person is going to kill someone or not, by the time you would have killed, okay? So there's all this practical problem. And now today I may be watching for 10 people, but then in cities where I live, like Mumbai, right? In fact, that is the place where we collected all the data, the Victoria terminals, right? Or what we call now Chhatrapati Shivaji terminals in Mumbai, or train station, the busiest, one of the busiest train station, where through its 8 gates, right? Can you imagine 8 lakh people cross those gates in a day, right? Now, if I want to monitor such kind of population, my programs, right, whatever I put should be highly scalable. And all that is also now linked to what kind of data I'm collecting for this. What's the resolution? If my images are fuzzy, I can't make out. What kind of video camera? What kind of storage devices? If that device data, right? It's not just about the algorithm or problem or solution. It has to do also with the data, how that data can be easily brought in, can be harnessed, right? And using all these things, we developed a solution, right, which was made available somewhere around 2009 in Europe, right? And what we did is actually we device a chip, right, which has all this algorithm, which sits along with the camera there. And whenever the camera is tracking people, this chip will analyze the video footage, will tell you, will do threat perception analysis and tell you what kind of, right, the persons are around, what's the threat there. So this is what is actually there. I have given you the reference, right, in which all this work is published, right? So what I've just narrated to you is a real life use case, right? So moving forward, right, let's look at now you're at this stage, right? You have looked at different things. Remember our slide 1 where we looked at the pattern, slide 2 where we looked at certain features, right? Like Mahatma Gandhi said, what are the things which tell you, which make you identify things, right? And in third slide, you looked at, right, almost similar thing, but still able to discriminate between what is real and what is not real. And now you have all used those kind of pattern analysis and information, and now try to also see how it can be harnessed to do some real life problem can be solved, right? From this basic ideas of pattern, right? Looking at the pattern and harnessing information. And now the stage is really set, right? That we can now talk about data science and machine learning. So quickly we will see what is machine learning. In fact, what you did in all this time is a machine learning. And then what we will see, how do we, use these machine learning techniques? Where is the data science? What the difference between machine learning and data science? And that is something that we will go through. And we will also try to see, now you are so much excited if you want to contribute to data science, what are the pathways, right? by which you can contribute. So here it will be a, say, 20-25-minute session that we will continue. So quickly, right, if we look at what we talk about machine learning or data science, the question that people ask me, okay, but then how it is different from programming, right? In programming also, right, we write down the software or program, it looks at the information, the data coming in, and try to give me a result. But what is different in machine learning here? Here, a user don't have to imbibe the logic of doing things, whereas he has a program which looks at the pattern and generates a new program automatically to give you the output. So whenever you want, so this is a kind of automatic learning system, right, that gets established in machine learning approach, right? That's how it is different. Now, coming to, right, machine learning and data science is a bigger domain, right, which includes everything, right? It has computer science, machine learning, mathematics, statistics, traditional software engineering, because end of the day, what we do, we take all these algorithms, model, and marry them into software. And traditional research, right, is one such thing. Research methodology, what we call about, is a very vital part in data science world, right? And all these things is actually complemented by your subject matter expertise, because you have to know your subject very well. Then you can look at this pattern, and these techniques or other things help you to how to see those patterns, how to harness those patterns. So this is what we call overall field of data science. A person who knows all those fields, we call them as a unicorn data science, right? But there are very few people like that. What you will see, each individual have a flavor of others, and right, expertise in one or two topics here. We will see as we go down the line what are those things. But then question is, when do we use this machine learning or data science? Typically in scenarios where human expertise is limited. Human expertise is limited by physical spaces, something like what we did for a rover or our own Chandrayaan, right? Where humans cannot actually go. We send these machines to analyze. If the situations are harsh, like certain like Martian environment or certain, those atomic power plant where humans themselves cannot stand by, our machines can stand by, and when they can do this machine learning or something, they can mimic the human thinking and utilize it. So there are multiple applications which I have put right on this slide in different domains, right? For example, retail, medicine, bioinformatics, you name it, right? As we go in this series, you will get to hear from some of our next set of speakers. Some of them are creating oil from algae, right? You will get to hear from the world's one of the best robotics company called Hanson Robotics. His CEO will be talking to you sometime later about robotics, where you will see how this machine learning AI is helping them, right, to create humanoid robots, right? And what they say, this robot and humans in future are going to live together. So what are the factors that what we call socially acceptable robots, right? That is something they work on, right? So multiple fields, it's just limited by your imagination, where your machine learning data science has its application, right? So in the next few set of slides, we'll quickly see what do we do actually from algorithm point of view. Broadly speaking, all this data science machine learning algorithms can be grouped into three. Something what we call supervised learning, unsupervised learning set of algorithm, then reinforcement learning of algorithms, and semi-supervised learning of algorithm. Right? We'll quickly go through, and then we will see how you can, right? If what are different roles that are there. So in supervised learning, you are looking at the old patterns. You have the factors which influence the output, and you have a record of output which came out of those factors, right? When you make use of both of this information, right, that labels, outcome as labels, right, when are available, that is something what we call supervised learning. What are those examples of this? For example, share market price trading prediction. How many of you are there on ShareCon or Reliance trading platform? You must have seen the projections for the day, right? How do they get that projection? They look at the old pattern, see which factor influence the market, and then based on those old patterns, if the similar patterns are there today, now they predict, right, with certain uncertainty, what is the output today. So those kind of algorithms are typically supervised learning algorithms. Experiments like one predicting the emotional state of a person and how it affects the electromagnetic radiation outcome from the brain, right? Some of those experiments now can be used to predict, given a measurement of electromagnetic radiation, we can tell what state the human being is. Again, because we have used past data of, given emotions, what was the electromagnetic radiation intensity, that information was utilized and labels was utilized. So this is one of the supervised learning algorithm. Weather prediction, right? We all know, we look at the past weather for a given weather pattern, whether particular day was sunny or rainy, right? We predict. So weather prediction is also a classical example of supervised learning systems. The next set of systems, right? Here are some of the applications of it. I mean, we can go on listing them, right? There are many, but it is just representative one. For example, face recognition, right? All of you must have used selfie, right? And must be using, right? When you try to take photograph, you get that bounding box, right? Across your face. Now that's a part of, again, right? Supervised learning based algorithm. Character recognition, right? You use scanners these days, we can do OCR, speech recognition like Alexa or Google Assistant, or multiple bots, what you can listen, right? So there are so many examples of classical, right? What we call supervised learning. Now, when those labels information, that is, I have only the patterns, but I don't know what are the outcomes out of those patterns. But similar patterns, similar factors will have similar outcome. If that is the case, right, we use this pattern without labels. And such kind of techniques are called unsupervised learning techniques. A good example of this is a software called Lingo 4G. Again, it's a document clustering and text mining software. If you do search, right, on your Windows laptop, right, whatever time it takes, this software makes use of certain data mining technique by which it can automatically, looking at the content of that file, knows what are the topics inside. And then when you type something, it recognizes what's the topic of your search. And then by that semantic search, it can actually easily fetch those documents easily and in a faster pace can get those documents. So this is one such application, topic modeling and associated search of unsupervised learning. This is very familiar to you whenever you try to go on, right, online platforms like Amazon or any of such, right, platforms. Whenever you buy something, they will say, okay, we recommend you XYZ product, right? If you buy, say, an headphone, they will suggest you to buy a mic as well, right? Now, from where do all it knows? It looks at the old patterns, right? What all different items people of similar type, similar age, similar income group have used, and then try to use that information to recommend, right, the product which is highly likely can be purchased by a person, right? There are certain techniques from unsupervised learning which we call association rule mining. A very famous example of this is a Walmart use case. They observed that on every Saturday afternoon, right, the sale of beer and diapers go up. They were intrigued by what is that? Why these are totally disparate product. But then looking at the pattern, what they decided, right? Those two shelves were almost very far, right? But then they brought this shelf together, right, close by each other. And then the beautiful thing is your sale triplicated, right? So, but what was the factor? It was those all daddies, right? Coming to supermarket on Saturdays to buy diaper, and being a Saturday, being afternoon, they used to also buy beer, right? And when those beer and diapers were put together, right, they were more than happy. So instead of buying one beer, they brought two beers, right? Because they didn't have to carry that together. So you see, these patterns, right, help you in multiple ways, right? And even if you don't know what's an outcome, but you look at the patterns which are similar and use that, right? That's unsupervised learning. Another good example of this is a blind source separation technique. If you have used those applications, right? Karaoke singing application like Smule, right? You can see all this thing in real action, right? There are 2 or 3 different singers, they call jam session, they sing together, but each one can individually synthesize, modulate his voice and create, good sound, right? Now, that is something is again, right, a gift of unsupervised learning. A very interesting application, third set of algorithm application is called reinforcement learning. Now, I always give an example, right? This is how we humans learn. This is called reward-based system. If you get a reward, you do that action. If you get a penalty, you don't do that action, right? A live example of this is like a child when it starts, when it learns to walk, right? How does it learn to walk? If you remember all those moments, a nice little kid, right, is actually crawling, then somewhere he finds a support, he tries to stand, everybody, family member looking at them starts clapping, oh wow, good, good, good. And then this kid feels happy, he starts giggling, and then he starts taking his very first step. People are more happy, they clap, and that's a kind of inspiration for this kid. And he takes second step, third step, he builds a confidence, yes, I can walk, mama, papa are clapping, right? So this kind of reward-based system is something, because it tells him, yes, do continue to do that action in that fashion. It's a correct action. And that's how it starts executing actions from the experience, feedback from the surrounding system. Now, this is how reinforcement learning works. If you write another, for penalty example, right? If a kid is scribbling something on a wall, if his parents tell not to scribble, or they just say, oh, don't, right? Just by his eyes, then that kid, right, looks at it, he realizes something what I'm doing is not going to get me reward, but penalty. So it stops doing that, okay? So this is a very good example, but all these things are again utilized in multiple fashion. Your chess games, right? Optimal control theory are some of those examples. Those who have played chess online, they know after 2 or 3 games, right, your computer program becomes so smart that it can recognize all your move in advance. Now, again, it did not know how did you perform all way, but then as and when you do a move, it learns those things. And where you have fared better, it tries to learn from you and do it better, right? So some of those examples of reinforcement learning. Many times people ask me questions, okay, this is all fine, but then how it is different than statistics, right? So we can say that machine learning, right, is statistics on steroid, okay, right? Or we can, because in statistics, the main focus is on certain principles, whereas whether I have my hypothesis is correct, whether, right, particular model will be applicable or not, what are the assumptions? Whereas in machine learning, what we are more focused on the outcome basis, right? We are not so much strict about hypothesis, but we are more strict about input-output mapping, right? So there are certain similarities and dissimilarities between two, which I have emphasized here in these 2 set of slides. But just to summarize now, right? We looked at those different algorithms in machine learning, primary 3 categories: supervised, unsupervised, and reinforcement learning, right? And we looked at certain examples. Now here I take a pause, and now what we will do, right, in our journey today, right, we have now seen what is machine learning, what are these different things. Now I give you a little flavor of what is machine learning doing in healthcare, right? That's my bread and butter currently, okay? So let's listen to it, right? So next 10 minutes, we'll talk about machine learning in healthcare. When you go to a doctor, right, what do? You describe your symptoms, doctor listens to it, he asks you, okay, what did you eat today, what did you eat yesterday, right? But not more than 5 minutes. It's not just because, right, he's not interested in you, because he has to attend other people as well. Second thing, too much of information is not going to help him. We humans, right, can at a time analyze only 17 factors at a time. Okay, so given all these limitations, right, he tries to look at what's the relevant information for the symptoms that you describe. But, right, and he cannot spend, right, even if you go to big hospitals, right, something, he cannot spend more than 15 minutes. But today, right, the information is not just verbal. We have plethora of information which is available for a patient. You just name it: genome, device data, metabolome, right? Epigenetic data, proteome, microbiome, right? You name it. There's a tsunami of information as far as patient health is concerned. Clinical data, right? You just it's just pouring in. And just to add to it, the social data, all your Facebook, Twitter interactions with other people are also going to help, right? To see certain patterns which are not evident. You may say, I ate something, but then if I see something on your Facebook, which is different than what you describe, right? I can say that you are bluffing, and I can use real information and do a correct diagnosis. But all this has to happen in 15 minutes. A human can only handle 17 factors at a time. So where to go? This is where our friend machine learning comes into play. Machines don't have limitations like humans to play with only 17 factors. That is where they can play with these thousands of factors, analyze those patterns, and help us take decisions. Machine learning in healthcare, right, help us to do decision making. In fact, we say that we don't do data science. What we do is decision science. But decision science is not so popular world today, not as popular as data science, what you hear. But believe me, few years from now, nobody will be talking about data science, but about decision science. Data science fuels decision science, right? And what we do today is decision science. Well, just to get a glimpse of how much data we generate, a per human being, right, in his life generates around 25 terabytes of data. How do you quantify 25 terabytes? How big or small it is? Just to give an analogy, right? If you look at Wikipedia today, you take all those articles, right? Each and every article from Wikipedia, its size today is 24 terabyte. Now you imagine, right? A human being, a single human being, generating 25 terabytes of data. And imagine now hospitals every day, if they are looking at, say, 10,000, 15,000 patients, how much amount of data is being generated. And that is where, right, our software engineering, our database engineering comes in. How do you handle such data? How do I find a particular patient, right, out of those 25 trillions or Googles, right, of a data, and get that patient records easily, analyze them, and get to that. That is where we are doing machine learning here, right? So this is a healthcare systems, right, where we make use of such enormous amount of data and look at the patterns. But then what is healthcare system, right? Healthcare system primarily consists of three major players. We call payers, providers, right? Then life sciences, and one more, right, which is common to all, are medical technologies or devices companies. So these are four major verticals, and what you see on the screen is a global market. No doubt, right? Healthcare is expensive, but it's expensive because of reason. One of the things that we try to work is using our technology. Can we make them affordable without losing the quality of it, right? So this is what we typically do in healthcare data science, right? So four major components, as I said: payers, providers, medical devices, and life sciences. Now, each one of them has its own set of problems. Payers are those insurance companies, right, which pay for your things. They would like to maximize their profit, right, without affecting the quality of care. So they would like to be proactive, knowing which diseases are prevalent, what they can do to inform patient not to go into particular regions, right? Like what you see with COVID virus, right? There are strict guidelines, right, which are issued by each of these insurance companies, right? Same thing is with providers or the clinics, hospitals, which actually treat patients. Now, if you can predict, right, what's the pattern, what's the seasonality of particular diseases, they can augment their staff, right, and take care of a patient. If there are thousands of factors which are required to analyze patient records, it's machines. Through machines, they can help patient to have an optimal treatment, right? So multiple ways in which we do data science for healthcare. But then what exactly we do, right? So one of the things is we consult them, right? Telling them what is required, how they can harness data science. For some of them, we do this model or algorithmic development given their data set, given their infrastructure. Whereas for some of our clients, what we do is we operationalize which already built model. take this model and put them in real life test, right? We saw what happens, right? The challenges with that security system, we have similar challenges. Imagine, right? 25 terabytes of data, thousands of patients, thousands of comorbidity. That is, but how do you operationalize? How do you make sure that whatever you predict is correct, right? All those aspects we take care in model operationalization part. Let's look at a small use case, right, to see how we do it. So this is a breast cancer use case. We know in the breast cancer, they use something called fine needle aspiration, by which they take a sample of a tissues around the region of interest, and then analyze those under microscope by staining technique, try to see what's the size of nuclei, what's the size of cytoplasm thickness, and multiple factors. And based on that, a physician and those a clinician will tell whether those cells are cancerous cell or not. If it's cancerous, it's called malignant. If it's non-cancerous, it's called benign cells, right? But then typical time for this is around 4 to 5 days minimum, right? The question that we ask is, can we use machine learning techniques and expedite this process? And today we have those techniques, right? By looking at the size, the staining, right? The diameter of those cells or nuclei, we have a model, right, which has almost 99% accuracy for at least breast cancer cells, right, of particular type, and that does in few minutes instead of days, right? So this is one such use case which I'm showing you on the screen. So, right, this is the business problem as I discussed, right? These are the steps what we do. We collect the data, analyze them for the pattern. We may have to clean that data, right? We do modeling, then do validation, and then showcase those things, right? Because we have non-technical audience to which we present. So in few slides here, right, these are some of the numbers what you see, right? And now this information can be used by payers, providers, right, for decision making, right? Payers can use them, right, to say, right, can calculate if the patient has high risk of getting cancer, then in advance they can, provide them a plan, possibly in the beginning of high premium, but that will take care of those increased cost of care during the cancer treatment, right? So all such multiple end use cases are possible using the knowledge use of machine learning in decision making, right? And as I said, we will have to cater to non-technical audience. So we create certain kind of dashboards, interactive app by which visually, right, it can predict what is exactly required to take those decisions of to go for a surgery or not for a surgery, right? So this is where, right, I take a pause, right? And now the question comes, right, with all that what you heard, right, about data science, machine learning in healthcare, I'm very sure by now you all must have been excited and must be asking, can you tell me how can I contribute to data science? That is something now we are going to hear. Okay? So to go there, first we should know what are different roles there in data science, right? You all must be knowing there is a data scientist, right? But data scientist is a person who actually looks at algorithms, looks at an outputs and try to see, right, what can be done with those things. He's more an algorithmic person, but he is complemented by other roles. For example, data engineer who actually lay down those different pipelines for processing. Business analysts are actually the domain experts, which help them, data scientists, understand the real challenges, real amount of data, what exactly is relevant for that business problem, right? And then they are the domain experts, which are there in data science team. Typically in such work, right, there are 10 to 15 data scientists, data engineers, right, multiple people working. It's very important that information flows smoothly between one person to another, and together they advance the solution. It's data and analytics manager's job is to make sure this workflow is maintained nicely and the outcomes are delivered in given stipulated time with given quality of deliverable. So these are multiple tools, right? multiple roles which happens, right, in data science. So now we will see how, if you want to take up this role, what all need to do. I presume that the audience today is 11th standard and onward, right? So for those who are in 11th and 12th standard, it's very important you study well. You study well about the mathematics. You don't have to be expert in mathematics, but whatever you learn, you should know those basic principles, okay? And if you can practice how you can use those basic principles in application, right? Something as simple as what you learn, like a matrix multiplication or derivative, if you can relate them to your day-to-day life, right? That's the first step in becoming data scientist or data engineer, right? Or to be contributing as a researcher in data science. So do your maths very well. Physics, and especially modeling, that is something you need to master, right? And that is what will set the foundation for you. In fact, when I write in my firm, right, when we talk, what do we expect? We tell them, right, you don't have to know very high end, right, mathematics. If you know, that's advantageous, but as a minimal thing, you should know your 11th and 12th standard mathematics very well. Okay, so that's what we emphasize. Okay. And then what you are seeing on a screen are different roles, what is required, what are the resources available on internet for to learn about statistics, to learn about data science, right? So you can go through this slide and see, right, how it is done. Again, some of this content are not mine. These are borrowed from internet to some of the very good friends of mine and some of the people who have kept this material as an open source and a Creative Commons library, right? So one such way to learn is offerings from our public cloud providers like Amazon, Google, and Azure, right? So they also have a learning path available, right, on their websites, and certain courses, hands-on session, tutorials. So you can go through each one of them. They have a specific learning path to become a data scientist, learning path to become data engineer, learning path for AI/ML for business manager, right? Also multiple things. What I'm showing you is one such thing. And now this course levels can be foundational to start with, intermediate or advanced as you go and build the skills, right? So that is something which I would recommend for graduate people, people who are undergraduate and graduate people can benefit from this path, right? So the way you have data scientists, you have the role of data engineer who actually maintains all this pipeline, does real ground level, right, work to make things happen. So again, you have a learning path for data engineer, right? Likewise, you have learning path for data scientist part again. But then question is, right, with all this, if this is online, I don't know, this certification, for example, are very valuable, are, you know, rev in industry today. And so don't consider them less than your degrees or something. They are much, much, in fact, many times valuable than your degrees. But if you really want to pursue this data science as a university education, then what are the options? You have options within India and abroad. Within India, institutions like IISc Bangalore, IIT Chennai offer graduates, undergraduate courses in data science, but sometimes they name it in different way. For example, interdisciplinary science or computational systems, right? That is something that you have to keep watch on. IIT Chennai from this year started offering online BSc in data science program. It's a 5-year extended program, which makes you really expert in data science and informatics. BITS Pilani, for example, have a dedicated weekend program, right, for undergraduates and graduates for data science. These are around 2.5 years on program, right? Some of them are short-term program for module-specific program available on BITS online program as offering of online program. There are multiple universities in US which offers bachelor's and master's in data science. Some of them to name are Penn State, MIT, right, Illinois University. But then you have a new option which is opening up within India. Most of those private universities and the private coaching classes have now tied up with foreign universities. For example, an institution like Great Lake Learning now has tied with Illinois University, and you get a joint certification and a degree, certification from Great Lake Learning and a degree from Illinois University, right? For around 2 years of program. It's like gaining a master's by staying in India, right? Great Lake Learning is one such example. Grey Atom is another institution which offers similar thing, right? So if you're looking at university education, these are some of the things what you can pursue. Now, this information is most relevant to undergraduates and graduates. If you are actually graduate and want to be a researcher in data science, then you have to pursue your post-graduation. Again, these institutions abroad and within India, right, are helpful to you. Something noteworthy for you that apart from US university, because most of in India are aware of US options, you have to look at options within Europe as well as in Japan as well. In Europe, right, there is a European level Erasmus program where different universities across Europe have scholarships for people to pursue their postgraduate and doctoral studies in data science. So do look at the website of Erasmus program. There are country-specific offerings. For example, in France, we have EGID fellowship, edufrance.com, right? Or edufrance.fr is a site where you will get the relevant information. For Germany, right? You have EGID is a body which it's again, right? And sorry, not EGID, it's a DAD, which provides different scholarships under its university graduation and post-graduation program. So do keep watch on them. October is a time when these things are published, and December, end of December, where these positions are closed. Whereas on Erasmus program, these programs are open a whole year, right? So keep a track and see if those things help you, right, in taking the decision. If you have any doubts or something, don't hesitate to connect with me or some of my colleagues, right, who actually help people choose those courses, right? So this is about a university education if you want to pursue, right? And now I'm sharing certain resources with you. If you are so much excited, look at certain data set, look at these journals, do attend some of these conferences, right? It's very important to keep pace with what is happening around us, right? And that is where, right, I take a pause and just present a summary to you, right? So what we have done, we just looked at a broad overview of what data science is all about, right? I have provided you certain examples, right, to see how data science is, what is it involved, how it is there in healthcare, and then we briefly discuss about if you want to contribute to data science, what are different roles which are open to you, and to get into those roles, right, what are the options you have, certain private institution, public institutions, private certification, right? So that is what I have all to share with you. Thank you.
I have a question, sir.
Yes, please go ahead. Is it Diskit or somebody else? Right? I'm not able to see you at the moment.
Diskit is back. You can give the
okay.
next
Right. I'll just answer Diskit and then we'll come to the next question. Right. What you asked, Diskit? What are the opportunities after graduation? So if you want to be a researcher, you have to follow your post graduation. Right. So that's typically a master's. It can be in India, abroad, or some of those private institutions, which I said. If you are more industry oriented, if you want to get an employment faster, the simplest way could be to get enrolled in those 6 months courses, right? And or do that complete certification from either Amazon, Google, or from Azure public cloud services, right? So that's the easiest way you can get into industry of data science, doing those certifications, right? And these certifications typically require at least 4 to 5 months of rigorous 4 to 5 months of preparation. They have their training programs as well. So you can find, maybe I will share those links with all of you, right, in that PPT, so that you can go through and see what suits you. Did that answer your question, Skip?
Thank you so much, sir.
Fine. Maybe a next question now.
Sir, I have a question to ask.
Yes.
Uh, I wanted to know how much data science today is, majorly affordable in the rural or in India, basically to the masses, with the current pandemic situation that we are going through. Do you think, this can be really a blessing to the current doctors or the healthcare infrastructure workers, in analyzing the number of cases or that kind of, with the historic patterns?
Exactly. What we technically call contact tracing, right, is one such application, right? If somebody has got, say, COVID-19, in how many people's contact that person has come. How many of you make
Yes.
use of Arogya Setu app? Do you make use of it or you don't? Did you turn on its Bluetooth capability or don't?
Yes, we do, sir.
Right? So that's the best example of how data science today, data science plus technology, right, associated with it, is the best possible way utilized today, right? Remember, India is one such first country to introduce this app. When all this was happening, I was in US till 8th of March, from 22nd of February to 8th of March. I was in US and I had really seen how much those people suffered because they did not have anything like this. Okay. Now today, because of this app like Arogya Setu, again, I'm not trying to advertise government of India, but put simple facts that we all should be appreciative about. One of the problem which I feel in India is we don't value our own innovations. We are so much blinded by what others do, we don't value what our own people are doing it. We are so much skeptical about it, but that's altogether a different subject. But Arogya Setu app is the best example how in rural setup this information can be easily utilized. Another good use of this data science technique, right? Something which we work on, echocardiogram. Today, you don't require a big machine of echocardiogram. Okay. There are, right? How many of you have seen those heartbeat measurement applications on your mobile? Have you? Something, right? I forgot the name. But there are many such apps, right? Which actually looks at your light, which is emitting from your battery, from your torch, and it can tell you what's a heartbeat, right? It's almost 90% accurate. It's the same technique, right? What is actually used in pulse oximeter, but using mobile plus a data science, because it has this corrective mechanism by which it can correct those signals. That's another good example. If you want real cardiogram on a paper, today we have just strip size cardiogram. One of my friend who is a founder of Alicore, right? It's a Bangalore-based company, which is actually distributing now all these small echocardiogram devices. You have to just put your fingers and you actually get everything printed and sent across to a doctor, which is 1,000 kilometers apart or 10,000 kilometers apart. Telehealth, right, is best such example. And I'm proud to say ISRO was the first one to introduce, ask Kashi, right, what we did with Narayan Rudalaya in Bangalore, right? We had all tele-based consultation, but there we are using a lot of this data to correct those signals, because when person is seen on a screen, he may not have good resolution. So there we use this data science technique to actually refine those images, right? Maybe refine their x-rays properly so that they are seen properly. So multiple ways it's being used. But to answer your question, I believe, again, this is my personal opinion, we are not exploiting that capability fully today. It's just 10% of it, or rather smaller than 10% is today being consumed by our people, especially in remote areas, right? Places like Ladakh, I just visited once, right? I was there almost for 15, 20 days, but I feel that this technology, right, in multiple ways can help, right, our regions, right, which are remote, especially medical facilities. If you ask me, our major expenses are for three things in India. One is medical facilities. Second is education, right? And then can anybody know what's the third one? The house, right? Now, in housing itself, we are using data science, right? We looking at the patterns, right? Weather patterns, looking at the local availability of certain materials. One of my friend in remote place in Maharashtra, right? He builds his own house. These are called earth houses. Okay, I can introduce you to those people where how they use data science for all those things, right? So again, right, to answer your question, yes, it is going to help us, but unfortunate thing today is we are not exploiting it fully.
Yeah, next question, please. Yeah, there's question in the chat box.
Okay, let me just open. Okay, this is from Poonam Gupta. Someone wants to study on their own with a job. Where should they start? Okay, that is where this Amazon, Google, and Azure certifications help you. Their courses are self-paced, right? And their certification is valued industry-wise, okay? So that's the best possible thing which has happened to us, right? In terms of those certification. And apart from that, if you want to have, right, kind of one-to-one mentoring with physical person, right? Then the places like Great Lake, right, learning, and like many, right, those are the options where they have weekend classes or remote, right, classes with certain assignments and certification every day. What your best bet, right, are those three major public cloud service companies certifications: Google, Amazon, and Azure, right? And then there is some emerging new things which are happening. Is there is a Spark is another kind of technology which is used in this. So Databricks is one such product. Their certification, right, is something which is gaining a lot of value in the market, right? So these are the four major things which I would ask you to pick any one of them and you'll be good to go. Did that answer your question, Poonam? Okay, fine. Anybody else want to ask a question?
Yeah, Tashi, I want to ask, but I will ask in the end because I want to give opportunity to students.
Please go ahead, sir.
Sure, thank you. Yogesh, one more thing which is very important now, though it may not be directly linked to your domain since you are in healthcare, but healthcare plays a very vital role in decision making. Now, is there any sort of any organization or government agencies to validate the data generated by a data scientist, because this data is directly linked to some decision making? And we have seen in the past there are lots of things have been happened in a negative way because ultimately the decision has been wrong. So is there any organizations or something like that?
Yes, there are different governing bodies, at least in healthcare and banking and finance domain, right? Which have actual protocol. In fact, all of us be aware, FDA, right? FDA in USA is one for US bodies. That's the regulatory body which actually says what your algorithms you have developed, they are good enough, data which you are generating good enough, you have to validate them, right? So FDA is one such example. Likewise, we have different, we call them as regulatory bodies, right? So there are multiple regulatory bodies. Within US, it's FDA and alike. Within Europe, we have CNS, Centre National for Normalization, CNN, right? So that's again Europe-wide body who only certified. So there are certain procedures, certain regulatory and compliance mechanism by which you have to present all your findings, get their approval. And they have a kind of panel of statisticians and experts who actually validate your studies, right? So there are multiple organizations, to be short, right?
And in the beginning of the slide, you have shown us some motion analysis simulation.
Yes, that's right.
So is there any algorithm that you have developed, or is some software tools that is available in the market for that?
Both, right? So it's a huge, vast field, right? In fact, yes, there are, in fact, open source software, right? We recently conducted one hackathon, okay, for a college student. An idea was to recognize yoga poses from the videos.
Okay.
Okay. Now, this same biomotion analysis is used there because when you do yoga, there are certain particular ways, certain sequences by which you do, right? If you do Surya Namaskars, it's a different sequence, right? If you do Halasana, it's a different sequence. But the way we know, right, looking at it, we train the machine using this biomotion analysis to recognize what are the poses. And as a businessman, right, we created an app which can actually tell you if you're performing yoga and those postures, whether those postures are correct or not. You don't require a human to monitor. You have a machine or robot friend who can tell you or communicate to you whether your poses are correct or not. So it's a both way, right? It's a software which is available, and we also develop, curate certain algorithms.
Thank you. And again, I'm requesting students to again ask questions so that I can again ask few questions if he permits me or Tashi permits me at the end. Thank you. So nice of you.
Yeah. Any questions, please?
Okay, and just to add, right, if you don't have questions, but if you get questions later, right, I'll be sharing my email address, right? Don't hesitate, right, to connect with me. Typically, I will also share my contact details, but then on weekdays it's difficult. If you people want, we can connect on specific time on a weekend, right, 1 hour or so. If you don't have questions now, it's not the end of it, right? We will be in touch. I guess, right, before our third time 45-minute slot gets over, I guess, Tashi, now it's a time to maybe, right, take a momentary pause. What do you think?
Yes, Shabir, you can ask the remaining questions, then we can wind up. Maybe students are hesitant to ask questions.
Yeah, thank you, Tashi. This is Yogesh. This is related to students only.
Okay.
You know, if I want to simplify, collect some, say, a data of set of people, and I want to further do some, you know, manipulation of that data in the sense of, you know, probability or implementing some mechanical tools,
right?
Sorry, mathematical modelings, say, extrapolation or interpolation. So can we use this Microsoft Excel for that, or which one
Oh,
you
yes.
prefer?
In fact, no, I advocate that, right? As I said, right, my first job is to democratize data science, right? There, for almost most of 60% of problem can be solved with Excel, okay? But it has its own set of limitation from scaling and other point of view, right? So, you know, right, you can handle only 65666. That's the maximum number of records you can churn, right, at a time. It becomes very slow if you have a huge data, right? So those limitations are there, but I always tell people to make use of Excel as far as possible to do data science.
Okay. Thank you. So nice of you. And it was very nice to be in touch with you. And you have really made me data science just like, you know, it's a,
okay.
I won't say it's
I'll
a cakewalk, but it's quite, you know, students can opt for this. Thank you very much. So nice of you.
Right.
Thanks, Sashi.
Yeah, Dr. Yogesh, I think the most of the students, they are in 10th, 11th standard, and some are in college. So maybe this topic may be too heavy for them. So they would not have understood properly. So just for the curiosity, I want to ask you, now we see the lot of, you know, advertisement, like, you know, future holds in artificial intelligence, machine learning and all. So like there are a lot of parents also ask the students to go for some coding at the like at the age of 10, 11. So what do you feel like, at what stage or what age is the right time for them to learn some this basic computer skills and slowly build up their you know knowledge at the, you know, very the fundamentals in the early age? What stage is the right time, and what kind of courses they should learn? Like there is, like, say, what kind of the small and very easy software skills they should learn?
That's my personal opinion, right? These days, it is parents which are more crazy than students. Okay, it's not needed for you to learn coding in the very beginning. What is important is to develop an algorithmic thinking. You know why Indian programmers, software engineers are held the best worldwide? It's not because the syntaxes and programming languages they know. It's because the way they provide unique and different solutions. And do you know why we could do that? In fact, they have seen now our quality is dwindling, right, of software engineers, and software engineers from Vietnam are much better than Indians now, the new age or millennials. Do you know why? Because our earlier generations, right, they used to feed on stories and not visual mechanism. So when you used to read or listen to story, they used to think and visualize themselves, and by that they used to have an ability to find a solution or visualize the solution in their own way. So many times, funnily, I tell, right, when all this, right, TV was not there, everybody's Ram or Hanuman was different, because they had just listened and they had their own image in their mind. And that made them to think independently, differently, unique way for each of the problem that today, unfortunately, because of all visual mechanism, this ability to visualize solutions, right, is dwindling. And if you push your students or if your kids at an early age, I'm seeing people and pushing their student, I mean their kids in 5th or 6th standard to do coding. By this, they are killing their ingenuity, because that's the age, it's a formative age where our brain is actually learning the skills of visualizations. And by putting them to regular coding exercises or something, we are killing that innovativeness of a mind. Because then you have to just follow rules, syntax X, Y, Z. No, in my opinion, those early ages is not needed. When you get into 9th or 10th standard, get familiar with the programming. Even if you don't do it, it's fine, right? And I would say when you get into your 10th or 11th, that's the right time for you to think, right? Whatever you could think algorithmically, how can you replicate that into a program? So that your algorithmic thinking is also captured in structured way, and that structured way is nothing but a program. We should actually do this, right? We should not get obsessed. I see some of the advertisement, what is that? Whitehead or something. You get a commercials on TV saying that there's some army officer telling my kid who wants to learn and all that. No, please don't fall to this propaganda. That's my personal request, okay? My experience and interacting with people throughout the world, and one of the best people in the world, right? I think that is what we have to learn. I will tell you a funny story, right? In France, right, they don't teach you writing till you get to the 1st standard. Just contrast it with what we do in India, right? What they teach them are life skills. How to arrange your clothes, how to arrange your files, how to think about things when you want to execute them. They take you to different places and narrate a story of those places. By that, they develop their own individual thinking. We are missing that. Please don't fall prey to such kind of propaganda which happens. That's my sincere request to everyone. What is important is to think in ability to think independently and capture that independent thinking in structured manner. If you can do that, programming is one such task you can kill in few days. Any damn programming language. Did that answer your query, Nashi?
Yeah.
I mean, I just gave my opinion. It's too opinionated, but then that's my opinion.
I really agree with you. Like when we studied, we studied it totally in in a different environment. Nowadays, a lot of pressure on the students.
Yeah, right.
Any further questions from the students or the audience? I think if there is no further questions, then we can wind up this session. Yeah, is it okay, Yogesh? Shall we wind up?
Okay, that's good.
Yeah.
Okay.
Thank you, Dr. Yogesh. Thank you very much for sparing your valuable time and sharing your experience and with the student from Ladakh. And there are so many audience I see. So thank you all for coming to this session and making it as a grand success. I think this is the first session under this emerging technologies. So today is a data science. So we'll have a lot of other lectures. So please stay tuned with us, and we keep connected. And we will upload into the YouTube channel. Please visit YouTube Ladakh Science Foundation. Till now, most of the programs are like in the Ladakhi local language. So now this is the lecture series we started, and I'm very grateful to Yogesh ji, and he has agreed to be the first speaker of this emerging technology series. And there is a lot of long way to go. So thank you very much. Thanks all of you all for patiently listening to this long lectures. Thank you very much. Thanks everybody. Thanks.
Thank you everyone. Julie, right?
Thank you. Bye. Thank you everyone. Thank you.